Hi there and welcome to our lesson today. It's going to be about enthalpy of solution. We learned last time about enthalpy of combustion and we said that was when 1 mole of a substance is burned. Today we're going to look at enthalpy of solution, and that is the energy change when 1 mole of a substance dissolves in water. There's a pattern here, and an enthalpy change is always going to be for 1 mole of something, and that's something you just need to make sure you are sure of in your head. Okay, so anytime it mentions enthalpy change, you're always going to have to calculate it for 1 mole. But we'll go on that and I'll explain what we're going to do today. It can be shown by this equation here. I'll just draw a wee arrow to show you what I mean. Basically, this starts off as sodium chloride as a solid, and what's going to happen is that's going to dissolve in water, and you can see now that it's split into its 2 ions, Na and Cl, and it's also got these wee AQ things here, right? They mean that the ions are dissolved in water. If you're ever asked to write an equation for this, this is what you would do. Now, the delta H value, that's just the energy change, that's the same as the wee E. This can be negative or positive, okay, so that's something that's a wee bit different compared to the other ones we looked at. If it's negative, it's exothermic, and that is because when you dissolve it, it's giving out heat energy. But it can also take in heat energy and cool the water down, and that would be endothermic. Now I'm going to show you the experimental setup that we'd use to work out this equation, this reaction. We could use a polystyrene cup with some water in it and a thermometer, and then obviously you could also have a lid on the top. That's not shown there, but you would want to put a lid on. Now, the reason for that is, using polystyrene and using a lid, is you want to try and insulate any heat energy from being lost or coming back into the cup from outside, okay? That could change your results, and you don't want that, okay? Any lost heat energy is why your calculated enthalpy might be different. It could be less, it could maybe be more as well, than the textbook value, okay? So if it's any different, chances are you've got heat lost to the surroundings, okay? So that would be your answer if you're ever asked about that. Let's do some calculations and I'll show you how to do these. We've got an example, and this is pretty much just the same as what we've been doing, except it's not when something burns, it's when something dissolves in it, okay? We're going to calculate the energy produced by dissolving 4 grams of sodium hydroxide. So this is the simple part, this is the easy part. This is simply just using E equals C M delta T. I'm going to zoom in because that gives me more space to write. Now, if you look at the question, it says 100 centimetres cubed of water was heated up by 5 degrees Celsius, okay? So our C, we should know this off by heart now, is going to be 4.18, because that's the specific heat capacity of the water that we're heating. Our mass, 100 centimetres cubed. Remember that changes to 0.1 litres. Oops. And then that changes to 0.1 kilograms. Oops. So this is times 0.1. The mass of water is going to be 0.1. And the temperature change was 5 degrees. Okay. And when I put this into the calculator, that is going to be 2.09 kilojoules. And because the water is heating up, it's going to be exothermic, so we'll put a negative in here as well. That is the answer. That is no different from what we were doing the past couple of lessons. Okay, so that should be quite nice and easy for you. The next thing that's maybe going to be harder is when we have to work out how much energy is released when 1 mole of a substance is dissolved. Okay, excuse me. We need to work out the gram formula mass of sodium hydroxide first. So we'll set it up, we'll do the gram formula mass, and then we'll find out how much 1 mole is. Okay, so if we put in 4 grams of sodium hydroxide, it releases minus 2.09 kilojoules. That's what we did from our first equation, or our first part of the question. We need to work out the GFM of sodium hydroxide, so its chemical formula is NaOH. Sodium is 23 and you've only got one of them, so we'll do 1 times 23. We've got one oxygen, so that's going to be 1 times 16. And we've got one hydrogen, which is 1 times 1. That all adds up to 40. So, 1 mole, which is 40 grams, is going to be the same as 40, and remember new over old times other side, 40 divided by 4 times by 2.09, that works out to be 10, 40 divided by 4 is 10, times 2.09, so that ends up being 20.9 kilojoules per mole. Remember the wee per mole part, this is because you're worked out for 1 mole, so every time you do an enthalpy and you're working out that actual enthalpy and it's for 1 mole, make sure you do per mole at the end, mole to the -1. And remember this was exothermic, so put the negative there. That is the answer there for you. For those that are liking the cross multiplying, I'm going to set that up for you just now as well. So it's going to be 4 divided by 40 is the same as 2.09 divided by x, right? And then you change that for x, so that's going to be 40 times 2.09, remember the wee point, and divided by 4. And when you do that, you get the same answer, 20.9 kilojoules per mole. Remembering that it's exothermic, okay, so it's got to be negative there. Good. Hopefully that makes sense. I'm going to do another example for you just now, and then you'll be able to see how you get on. There's also going to be some more calculations to work through as well in the attached sheet. Okay, so this is a wee slightly different. Let's first calculate the energy produced by dissolving 17.2 grams of lithium bromide. Notice it says 50 mils of water and it's heated up by 10 degrees Celsius. Okay, please remember not to get confused by the mass. Remember it's a mass of water, so you'll change this 50 mils, not the 17.2. That will come into play later. So E equals Cm delta T. C is always 4.18. Mass is going to be the mass of water. That's going to be 50 mils, which is the same as 0.05 litres, which is the same as 0.05 kilograms. So mass was 0.05 and the temperature change was 10. That means that we end up getting exactly the same answer by chance as the last one. So it's minus 2.09 kilojoules. Remember it's negative because the energy has been released to heat the water, so it's exothermic. Hopefully that makes sense. Let's move on to the next part. Let's work out the enthalpy. Okay, so we said that 17.2 grams of lithium bromide gave us minus 2.09 kilojoules of energy. Now, let's work out the gram from the mass so we can find out the mass of 1 mole and then work out the enthalpy. So lithium bromide has this equation, formula. Lithium has a mass of 69 when you look in the data booklet, and bromine has a mass of 79.9 when you look in the data booklet. That all adds up to, sorry, I've read my writing wrong. This is 6.9, not 69. That all adds up to 86.8 grams. Okay, so that means that 1 mole, which is the same as 86.8 grams, is the same as, and we'll do new over old times other side. That means to work out this, you'd have to do 86.8 divided by 17.2 times by 2.09. And when we put this into the calculator, we end up with 5.047 times that 2.09. Remember, you want to kind of try to do that first if you're using an older style calculator, just that you're not messing up the order of your calculation. And then you want to do that, and the calculator will give you 10.55 kilojoules per mole. However, we said this was exothermic because it heated the water, so it's a wee negative there. Okay, and that is how you do the enthalpy of solution for lithium bromide. For those of you that like the cross multiplying, I'm going to do that just at the bottom for you just now. So we said that 17.2 divided by 86.6 is the same as 2.09 divided by x. X is going to be 2.09 times by 86.6 divided by 17.2. That answer comes out to be 10.55, just the same as before. And it's negative because it's exothermic. There you go. Hopefully that is making sense for you guys. If you guys are getting stuck at all, obviously you know you can ask your teacher. Hopefully that makes sense though. Good luck with the questions.